Okay, hi everyone. Welcome to February's Edinburgh Reproducibility. Today we're going to be having a discussion about teaching reproducible and open science to undergraduate students. And we're joined here today by Emily and Patrick, who are from King's College London. And they're going to be talking specifically about neuroscience and psychology, but perhaps we can have some discussions about how we can broaden that up as well and what might be applicable and what might need to be changed in our discussion. So I'll let you take it away, Emily and Patrick. Thanks for joining us.
Thanks, Emma, and thanks for the invitation. So before I really start, I've got a few acknowledgements, which are around who should be acknowledged for the course and the content, and also who we're putting it on. So also we're giving the talk, and I'm currently the one of the deputy course leader for this course. I definitely didn't design that curriculum. I joined King's Neuroscience and Psych team in 21 when it had already been on for a year. So Yanis essentially designed the course, and Sam on the slide has been doing a lot of work about promoting what we've been doing. Andrew and everyone after them are also people contributing to research method teaching, so very core into the open science, but that's not the only people. So all the team should be acknowledged. And Andrew, when he built the research method teaching for year one, also really built on from our BSc psychology only, so single honors that we have. So those people also should be acknowledged. And finally, because we were absolutely not the first ones in the UK, the Glasgow team was the first one to introduce R in their course to undergrad psychology. So Lisa and everyone else at Glasgow really should be acknowledged, because that's been a lot. We're always looking at what they're doing, and they're big inspirations for us. So really, this is a very modest contribution. It's also very much thought in progress. It might even sound a bit rumbly sometimes. It's very much, we're doing this and this is how we're thinking about it. And it's not necessarily very developed yet. That's purpose is to have a chat with everyone. So I'm really looking forward to the questions and your thoughts. And maybe there'll be some inspirations for you, but maybe you'll get us some inspiration too. So we're really here for the exchange, and we hope you find this interesting as much as we enjoy teaching it. Can you change Patrick, please? Okay, so I will be starting with some context and why we're doing that. Like, obviously you're here as reproducibility attendees, so you do have clearly some interest in the topic, but I will give still some context about this. Then I'll present our curriculum as simply as I can. Talk about specific aspects we do that are probably more the ones I know more, and probably forgetting some as well, where we embed open science in other modules and research method, but also in research method. And I'll talk about the challenges, which I think is probably the most interesting part, and vague short ideas for the futures. And Patrick will talk about the student experiences, his view as an alumni on the course, and then we'll open the floor for questions. Next slide. Okay, so the context, like I said, we're all reproducibility regular attendees in different places. So we do understand, and I don't assume everyone is from psychology, but the replication crisis goes beyond psychology nowadays. So, but 14 years ago now, I'd say about psychology at least had a really big wake up. We had the BEM paper in 2011, and we realized that you could publish a paper saying that people can predict the future. And we're like, oh, wait, maybe we do have a problem. So that started quite a nice bunch of things, particularly at first a bunch of replication studies, all the mini labs, the open science collaboration study. And from this, a bunch of practices developed, like practices that people have adopted more and more, such as pre-registration, which now journals tend to require, thankfully, and people started sharing their data, which again, some journals now require. We moved on to registered report, which in my opinion, and that's a very personal opinion, are very much the future of publishing papers, because they really are a good way to, reduce questionable research practices and also publication bias at the same time, while still helping people do what they're supposed to do and what is their promotion currency, which is publishing papers. And that also has been really interesting. The governments in Europe, at least, and in the UK, definitely, have been looking, and funders as well, at what we're doing and asking more transparency and openness, which is, well, also what we need, because how do you make people change their practices is by making the people who pay them, asking them to. Unfortunately, because we all have not such a long time to do our jobs, and really we can't do everything at once. In all of that, we've seen more teaching happening, but not necessarily so much. We've got, I think we don't have many papers, for example, already who looked at this, but those 3 papers have. And for example, the one I know most, because I contributed to the Bonwell et al., we did a review of what's been published about teaching open science and open scholarship to students, not specifically undergraduate. And what we found is there isn't a lot that has been happening, for sure. And we did find a lot of things on postgraduates, but not so much undergraduates. So that signals that, one, teaching open scholarship and open science hasn't been really happening, and definitely not at not much at the undergraduate level. As far as I know, in the UK, I'd say, people teaching are, for example, and further than are open science to undergraduate student people courses are probably less than 10. I mean, very definitely, actually, very surely less than 10, and I'd say probably around 5. And like, as I said earlier, we definitely were not the first one. So there are good reasons for this. When in my previous job in I was in Kingston University, and I was working in business school and tried to promote open science already. And one thing I was trying to do is to get people to move from SPSS to teach statistics to free software, which are equivalent, like Jamovi and JASP. And so I developed some talks, and I talked to my colleagues about it, and they were like, yes, that's super interesting, but we don't have time to redo our teaching material. And it's completely fair. I just said 2 minutes ago, we have, a limited time to do our job. So redesigning your curriculum, redesigning your courses, that takes time. And we don't have that time. The market, the higher education market, is completely on fire right now. So people have, other things to do to save to keep and save their job at the moment. And asking them to redo their course to teach and retrain themselves maybe is obviously a big ask, which is definitely going to be a large barrier to the teaching of open scholarship. And in this, I'm assuming that teaching R is essential. I mean, teaching at least something open course and coding base is probably essential, because while Jamovi and JASP have some reproducibility embedded, really teaching statistics with R also adds to this, because you're gearing students to learn other languages, and then they can develop further practices in terms of developing their own software and having their own software open. So to go back to the kind of barriers, the structural barriers, yes, it's understandable that people haven't moved to teach open scholarship, because it requires a lot of time. And I want to really acknowledge that we are actually so really privileged. It happened for us because the course is new. It started 5 years ago. I mean, not even 5 years ago. So it started in 2020, and it was built from the onset to have those practices in, which means that people who are hired to teach on the course, like I was, specifically in, having those research, those practices already with them. And so we didn't have to retrain. I mean, technically I actually did, but that's a different matter. And we didn't have to create new curriculum because we were new to the job. So that was kind of part of the deal anyway. That's a bit, confusing what I'm saying. That also relates to another privilege, which is in King's, as other places have. I think possibly you have at Edinburgh, I know Glasgow has, is we have education track staff, and we have more research-based track staff, more research-based staff. Education and research do 60% of their work on teaching. We, in the education track, do 80%. So, and that means that we can be hired really specifically for a course. So me and all the people I've put on the slide at the beginning, we are actually specifically attached to this course, which also gives us stability. So like everything we develop on the course, we know that the staff is dedicated to it and is not going to move to another module because they are actually managed at the course level. And it's a really great privilege, and it's definitely highlighting how much the barrier is structural also to teaching or open scholarship. But another barrier, and I think that's where the talks comes in, is sometimes people think that, student can't do it at undergraduate level. One more reason to do it actually at undergraduate level rather than master level, and that doesn't say we should stop doing it at master level, they should, because obviously there will likely always be students who haven't done it before. When you have masters, they're very international, people come from very different environments. So it should still be there. But if you do it on undergraduate level, you have 3 years with students to develop them. And on this, you can actually touch on a lot more things. And then what's important, I realize, is you actually also train, when you teach undergraduate, that's probably also why people don't do it. It's when you teach undergraduate, you're not teaching people who are all going to go in academia and do research. So why would you teach them those things which are very specific to research? Well, actually, you should, because yes, people are not going to be all researchers after their undergraduate degree, but they are all going to be, in a way or another, a consumer of science. And consumer of science should also understand open science practices and the need for them. And because then they look at the science they consume and they use in their day job in a way which hopefully is more critical. So that's also a very good reason to start at undergraduate level, in my view. Patrick, next slide, please. So how we do it. Sorry, I'm just going to get up a second because I need to blow my nose. Oh. And that definitely doesn't play well on camera. How we've done it within the curriculum, and to be honest, it's strictly within the curriculum at the moment. We've been thinking about having other things like, a coding club. Glasgow has one. I would love to have a coding club, but also I don't have infinite days. So it hasn't happened yet. So at the moment, it's really pretty much all within the curriculum, except 1 or 2 small initiatives. So we teach research methods with R for 3 terms. So the first of so obviously we're 3-year degrees because it's in England and we don't have 4 years like you do, unfortunately. That'd be a lot more fun. But so we have 3 years to teach those students about open practices and particularly R. So within research methods, we have R, and all our seminars also, which are in RM1 and RM2. So in the first year, are focused on, writing transparently, doing research reports, doing research in a transparent way and reproducible way. So this is obviously the foundation and is really critical. But we also have all the psychology modules, which are for BPS accreditation and are therefore core in orange, where there will also be some use of R. I have left it on some slides, but on some of them on the slides, but actually more of those have it. So generally, when we have a practical associated to a psych module, and that practical involves quantitative data manipulation and analysis, we make them work with R because we know that's what they're using. So we're reinforcing that obviously open science and research methods are core to everything, and they really don't live in a vacuum in research methods module. And then we have a bunch of blue modules which are essential for the neuroscience aspect because we are joint owners, so they need to have credits in neuroscience. And in those, in year 2, term 2, we move out from R and they move to MATLAB. I won't say we because I don't teach MATLAB. So in that term, they start using MATLAB in computing for brain scientists, where they start learning about computational neuroscience, and that links to the EEG module, electrophysiological brain, where they also learn to actually practice EEG and collect data with EEG. And I think, actually, I can't remember exactly. In the cognitive brain, there's some use of software as well. So there might be some coding elements there. And finally, very importantly, in the year 3, the research project obviously carries on with this tradition. So research projects, if they analyze their, I'll come to that the next slide actually. So research project, like everywhere, which obviously would involve some data analysis, so they might reinforce their R skills or their MATLAB skill, depending on the projects they chose. And importantly, they have 45 credits, which needs to be in neuroscience in their options. So, and in those options, we have 2 modules, which are term 1 and term 2, which are based on Python. So a student could very much go through the course and learn 3 different languages and come out having learned a lot of reproducible skills through those 3 coding languages, programming languages. So R, MATLAB, Python. And if you go to the next slide, Patrick, I'll talk about the more embedded bits. So we don't throw them, in the deep end of the pool straight away. When they come into year 1 in RM1, so research methods 1, they start learning R, and we assume no previous knowledge, so it's very foundational. Like the first week is, here's RStudio, and here how you work, and here you install it, and also here's how you find your working directory and things like this. It's very, very slow in the first term. It's also base R oriented. It's only base R actually. We don't talk the team doing it, I don't teach that module, I only teach RM2 and 3. They talk, about base R only, never mention that package exists. Curious students will probably realize quickly that package exists and can help you, but it's not part of the learning outcomes. So it's very, very foundational. And apart that, we don't touch too much on practices. Psychology and the brain, the psychobio module is a term 1 module, so they use a bit of R in there to analyze some data to, again, make the link with the psychology module and the need really force that it's everywhere. But that's about it, except that about week 8 and 9 in RM1, Tony Trotter and I, we come in and we have a little lecture on this is a replication crisis. This is what's been done about it. So this is 2 hours where we start with, like I started at the beginning, there was, there's a story about BEM and feeling the future and a few other papers, and we give a few examples of questionable research practice and questionable papers. And we quickly move on to what we can do. So we actually base the talk around the science cycles that you might have seen, which, for example, is in Chris Chambers' book on the 7 scenes of psychology, such as a science cycle going from literature review to publication. And at each point, you find out which questionable research practice could happen. And so we just go around, we're like, oh yeah, so literature review, well, we have problems with foundations, theoretical foundation in psychology, because sometimes they're quite shaky and we don't have very formal models. And then we move on, to practices around, so we talk about p-hacking, etc. And because it can be quite a depressing talk, you can get students to be very cynical and be like, why am I here then? I'm learning about science, which is actually quite unreliable. We move on to the things, all the things that have been done, and we talked a lot about big team science that's been done, projects we've been involved on, and we explained how we do things and how we hope we introduce registered report very briefly. So we try to also show that there is a way out, and we use that to explain to them. That's also why we teach those to them, because it's important to us, and we think it should be important to them. Then, sorry, like I said, in all modules we use R when there is data. So in all the psych modules, so that development, the development module in year 1, term 2, the others as well, I'm sure, and choices, which is my module, involves, which is a year 2, term 1 module, has a lab report, so the analysis needs to be done in R, and that reinforces again the link. And generally, the analysis is an analysis using techniques that they've been learning in their research method module, that same term, which is research method 3. In the research method module, on top of the R teaching, we have specific requirements, which we were really, really pedant, I guess, about it. Like some students sometimes don't really understand. I have an interesting story about this. But we're really insisting on the importance of commenting, and that is really important for reproducibility and transparency. So we give marks specifically in all the assignments. RM1 and 2 have live coding assessments in limited time in class. And for this, they have commenting marks. And in RM3, it's an exam, but it also involves doing some coding. And again, it has marks specifically for commenting. I said I have a funny story. It's actually a sweet story. I really like this. One of the students last year was asking why they had lost mark on structure. I was like, there is no commenting in your code, so this is part of the structure criteria. And he was asking why it's important. So I pulled out Patrick's script of his some work we were doing together, and I showed him the script. I was like, this is what my student is not doing. This is obviously a lot more complicated than what you've been doing so far. And when he shares that to me as a supervisor, how am I supposed to understand if he doesn't comment? And the same student in his RM3 exam, I ended up marking it. It's been so much more commented. I was just really super proud, and at least we won with one, so I'm really, really super happy about this. The other thing we also do, which is very much oriented towards open science in the stats elements of the research methods module, that from RM2 we introduce Bayesian approaches and Bayesian theorem, and then from there on, every technique we introduce has its equivalent introduced, its Bayesian equivalent introduced. So they learn to do t-test in a frequentist approach and in a Bayesian approach in RM2, and in RM3 they learn the ANOVAs, all the flavors of ANOVA in a frequentist and in Bayesian, and then the same as they also learn linear regression, multiple regression in ANOVA and frequentist and Bayesian. I said earlier, RM1, 2, the seminars are where we built also a lot of discussions around, the need for transparency. We have in RM2, which I teach directly, and I manage specifically this series of seminar. It's very oriented about writing a lab report. They will write their first lab report at the end of the module. So we talk about how you write a good, transparent, reproducible replicable lab reports. So we talk about, the information you need to give and how you decide when it's important or not, which is obviously difficult because it depends so much on the context. And we have those, we generally do this teaching in pairs, and sometimes even trios. So Andrew develops the module, used to teach with me and Tony, and we have discussions with the student and in front of the students where we also explain, well, myself, I would do it like this because my field is more like this. And we really hope that that kind of discussion reinforces that there isn't a recipe as much as we would like to. There isn't a clear recipe and it's quite dependent. And we hope that giving them all those contexts and experiences we have really helps them with this. And then very, very critically, we do introduce pre-registration. I introduce pre-registration in the choices module. So in that module, they do their second lab report of their degree. And so they have to do a pre-registration, which is worth a very, very small percentage of the module, which is also a good way for me to check that they actually understand what is being done for the lab report and give them formative feedback towards the lab report. And then they also have to write up, do the analysis and submit the code for the analysis. So this year, for example, we moved on to qualitative instead of quantitative, but similarly to what you would expect from quantitative analysis, I asked them to also submit their code book as part of their report, and they would lose mark if they don't submit. So there are specific marks assigned to, transparency essentially, and being able to share what you've done and justify what you've done by sharing your material, and specific marks for pre-registration, and that also prepares them for their final year project, which was developed by the psychology degree and is shared with the psychology degree. It's the same module for both, because we also share supervisors. So I supervise people from psychology, and psychology supervise some of our students. And in there is also, again, a pre-registration at the end of term one, which is, again, a small percent of the module, but it's really essential because that reinforces the importance of declaring what you're going to do before, and also provides an opportunity for formative feedback. I want to go back because I just remembered something I didn't put on the slides, but one of the most interesting discussions I have every year about the pre-registration is that students are concerned, and I know very often scientists are also concerned about this when you introduce pre-registration, about, and what if I make a mistake and I need to change? And I'm like, that's fine. You can deviate from your pre-registration as long as you are transparent about it. So you can make a footnote, and it happens very handily that I have a paper where we had to do that. So I just give them the paper as like, look, in this paper, we made a mistake. We literally couldn't analyze hypothesis 3 because we had declared, because actually it wasn't possible. We were essentially stupid. We didn't obviously write this in the paper, but in other words, we did. So we have a little footnote, and I show them this example, and hopefully I hope I can reinforce that this is absolutely fine. I think that's actually what the marking was doing this week, and I think this year it's been quite nicely adopted by the students. So as I develop my own modules over the years, I think it's definitely starting to work well. Patrick, please change the slide, and then that'd be about my last slide almost. I think I somehow touched on some of those things as I was speaking, but to just like formalize them, it's obviously not without challenges. There are a lot of questions, things we are actually not sure yet. You probably are wondering about those, and my answer would be, honestly, I don't know yet. Obviously, so I mentioned we're joint honor degrees, so we have a lot of things to do, and we are only doing it in 3 years, unlike Glasgow and unlike anything you would do in Edinburgh. At the same time, and in the adjoint honors, we have, very strong requirements from BPS that we need to fulfill. And but we also have an institution right now who would like us to have only 2 assessments per modules, which when you're trying to assess 2 disciplines to give a joint honors degree is actually not that easy. And you probably have noticed there is, except the vague mention that I did some qualitative in choices, there is pretty much no qualitative in our degree at the moment, which is a problem and absolutely is going to be critical when we come back to the BPS next time. It's so much so that our students, we actually tend to develop students who are so quantitatively oriented that they think that measuring, doing a survey with scales is actually qualitative work. And we are working now on rectifying this belief from year 1 and say, hey, by the way, measuring things on a scale in a social psychology study, for example, is not qualitative, it's still quantitative. So there's definitely things we haven't achieved well yet, and things also where we like juggling with between tensions and we're still like trying to find a way. And the results also of those tensions is that, well, it's really packing a punch. For the students, it's very, very loaded, and anyone would be perfectly entitled to say, well, surely you're losing student on the way. We are admittedly a little under benchmark progression within our institution. We were just reminded of this week. Often, it's not to say we're not losing students because it's packing a punch. But I mean, it's a joint honors program. Students have obviously chosen to do a joint honors, so we do expect that they expect something quite demanding. But often often maybe half the cases, it's the case that the student will actually move on from the degree because they want to do something else. I had 2 withdrawals in recent months where the student went to study medicine either with us or somewhere else. The common case is students who actually want more neuroscience, more bench-based neuroscience, and that's not us, that's pure neuroscience, so they transfer to the neuroscience degree, and vice versa, students who actually want something more purely psychology oriented, so they move to the psychology degree. So those I'm not worried about. I do think there's some attention we need to put towards this, but we have built-in mechanisms which also work for sure to an extent. So we have in RM1 and 2, when they have their coding live assessments, there is systematically a formative coding live assessment where they can have the same structure of assessment in week 5, and then the summative one is in week 10. So they don't go completely in the dark. And importantly, really quite importantly, after RM1, students who have failed the coding element, so they generally have passed the module, but they didn't do well on the coding, will have one-to-one or very small group support session with Tony, in addition to their RM2 module, to make sure they actually don't fall behind. And there's been success stories in this. I have a personal tutor who was actually in that situation in RM1 and who is now absolutely striving. Did a placement after year 2 and really, really picked up during her placement, thanks to a really great placement supervisor as well, and is now striving. So it's something we have to keep an eye on, but not something which is dramatically worrying as far as we can, as far as we think, and as far as we can say. More practical challenges is working with psychology. We have students who develop their coding skills for 2 years, and then if they end up doing a project supervised elsewhere, either in psychology or more bench-oriented neuroscience, those skills might not be supported by the supervisor. So what we have is we have a dedicated teaching team. Us are providing stats support session for our students. So if a student needs some advice on their analysis, then their supervisor can give it to us within the languages that our students want to use. We provide support. To an extent, one colleague from Glasgow once told me that, maybe we were over-preparing the student. So, and there is some argument to this. We've had students going to master and coming back and saying, oh, well, some of the stuff I'm learning, we've learned them with you already. But that also means that we've had students going on the market, on the job market with really strong skills, which has made them really competitive. So, and I think that's what attracts students to us. So this is not something we're thinking of taming down at the moment. And as a joke, we're still teaching MATLAB, and it's not technically open because it's not open. It's still under license. So, but that's a joke. Sorry, that's my stab into MATLAB. Sorry, Patrick. I think I'm done. Oh no, sorry, I'm not done. Just quickly, some ideas. I had one yesterday, but I can't remember what it is now. So I had 3, but now it's 2. Things we are thinking of doing is a registered report in RM2, which is actually would be a way towards this need to have less assessment, because that would be a way to combine the lab report and the live coding. So what we would do is the analysis for the lab report will become the live coding element, and therefore they wouldn't be. That would be a single assessment on it in itself, but would still provide live coding environment, because being able to code under time pressure is important, given that a lot of our students are also actually more interested into going into data science careers, where part of the recruitment might be to do some live coding. And because we're growing in size, we now have a year 1 which is 100 students for the first time, and we should stop at this size because we have a strong need for labs. We would like to have more final year electives, so one of them would be to do more advanced R stuff, such as nonlinear methods, text mining, things which might be handy for dissertations, so in term 1 of year 3, but not necessary for PS requirements and for everyone. And if I remember my final idea, I will mention it in the discussion maybe. Patrick, you want to go?
So yeah, hi. So my name's Patrick. I'm one of the first cohort from the said course, and I had the fortunate opportunities to keep working on with the relative open science area, and now in the master that's also focusing on open science. So I just want to quickly share that the 3 core experience I feel like is related to open science in our course. That is the preregistration part, the coding and collaboration projects that has been mentioned in Emily's slides previously. So in Emily's module in choices, we actually been trying to involve more in a lot of open science. So this OSF page was one of the yearly project that was part of the CREP that's focusing on replications. And we also try to do some conceptual replication in our first year, and now more on qualitative replications. We also try to, like we were saying, that the examples of commenting. So this is my final year project, but like Emmy was saying, like some students might be more computational heavy. I was one of those students who took both the computational heavy modules in the 3rd year. But what I really wanted to show you is that it's not the outliers that I'm showing right now. Sorry. Okay, there's some error, but let me show you this way. But this one is actually what we expected from the exams in the first year in 2nd term, or the 2nd year 1st term. What we hope for them to understand the importance of commenting, and how that might help not just for the markers, but just in general. We had the opportunity to join like many analysis projects, to join some replication games, and often the critiques that we find and we commented on is that the lack of transparencies in terms of coding that doesn't allow us to do replications. And this not only has helped the markers to understand what the code is meant for, but also good good for students to understand why they're writing these codes instead of just copy and paste it. And then further than that, I want to quickly share the presentation part. Like choices, we actually use the OSF templates in depends on the projects. But in final year, that's also helping those from psychology students who didn't really involve in presentations, that allow them to self-reflect of their own projects, especially like for undergrad, the project is often pre-ethics approved. This allows them to actually understand what the project is about, what is their proposed analysis. So it not only helps them to understand why the presentation is needed, but it also just in overall help the whole thought process of like how the project is proceeding. But yeah, basically, one thing that can be really clear to see that is that those who are from our course when going into the final year project, in comparison to those who haven't experienced it in open science and R in psychology, it's easier for people from our course to also transfer it to other language, not only because we learned the 2 languages already, but we also know more, because the most challenging part from students' perspective in R is that it's harder because of the flexibility of what R can do, but it also allows us to understand why we're doing each of the analysis, like what needs to be input, what was the function that's needed, what kind of potential like post-hoc tests, what have algorithm that can be used, more so that when they transfer it to like SPSS or Jamovi or other languages, it's easier for them to just input their knowledge into it. And it also allows them to think about their project more critically to begin with, and that makes it easier for them to transfer into not only final year, but also to the master levels. And that's it.
Thanks, Patrick.
Thank you both. That was a really great presentation. I'm just going to switch the recording off, so goodbye anyone who's watching the recording, and we'll go on to the discussion.